This lesson we're going to look at the properties of squares, rhombi, and trapezoids. We'll be cutting this lesson up into a few pieces and maybe even doing a little project with a foldable to do some notes for us. So you'll be able to apply properties of squares, rhombi, and trapezoids to determine the measure of sides, diagonals, and or angles in the figures. So the first one we look at is a rhombus. A rhombus is a parallelogram with four congruent sides. So the first thing I notice, it is a parallelogram, and all those properties about parallelograms will be true about a rhombus. And then a few new properties. Okay? So we're going to look at these properties, and then later I'm going to have you make a foldable with these things. So I'll show you an example of the foldable, and each flap will have one of these properties on it. We'll entitle it property of rhombi. You'll see the little one I made, and you'll make yours a little bit better than mine. Okay, so let's look at the first property. The first five properties, you can see that they don't have any little stars by them, because that's all from the fact that it is a parallelogram. A rhombus is a parallelogram. And so these first five properties are the same as a parallelogram. The starred ones are the new ones, okay? But we'll put them all in our foldable, and we'll make another one for squares. Let's see. So the first property, since it's a parallelogram, do you remember? Opposite sides are parallel. So we use these little triangle marks to show that they're parallel to these opposite sides are parallel. The one triangle is parallel to this other side opposite with one triangle and two. So on one flap of your thing, you're going to put property number one, opposite sides are parallel, and draw this little picture in the flap, okay, to remind you of what it looks like. On another flap, number two, opposite sides, since it's a parallelogram, are congruent. And we'll see something else about sides. We already saw in the definition that all the sides are congruent. But parallelograms say opposite sides are congruent. So it looks like this right now because it's a parallelogram. But you'll see in number 6, since they are all four sides, we'll do that also. Okay. Let's see. Opposite angles of a parallelogram are congruent. Same in a rhombus then. That picture looks like this. Here we draw our rhombus, and we see that since it's a parallelogram, this angle equals this one, this angle equals that one. Since it's a parallelogram, consecutive angles, like in a parallelogram, are supplementary. So I drew a picture something like this. I drew a different one for another one earlier. But this is just trying to show you that, this angle and this angle right here will add up to 180. These are consecutive angles, and this one and the one over here, consecutive. These two will add up to 180, and so forth around it. Consecutive angles, any pair of consecutive angles will be supplementary, add up to 180 degrees. And the last one from parallelograms, the diagonals do what? They bisect each other. So the picture for number 5 here looks like this. Bisect means to cut in half. So this one right here is cutting this one in half. So these pieces are equal. This little piece equals this little piece, and on this one, this little piece equals this little piece. The diagonals are not equal to each other, okay? But it cuts each of them in half. Now we come to the first new property, since it is a rhombus. Those were just because it was a parallelogram. Again, it has four congruent sides. That's in the definition. It was a parallelogram with four congruent sides. So number 2 said opposite sides are congruent, but really all four sides are congruent in a parallelogram. They're all the same measure. Number 7, a new property for rhombus. The diagonals are perpendicular. Perpendicular means they intersect at a right angle. So the picture for that one, and again, you can pause these. I'm going too fast just because I got a lot of information to cover. So these diagonals intersect at a 90-degree angle, perpendicular. So all these angles in the inside here where these two diagonals touch are 90 degrees all the way around. 90, 90, 90, 90. We'll get some problems like that where they give us want to know the measure of that or figure out. And then the last one, the diagonals do what to opposite angles? They bisect them. So here the diagonals actually bisect these opposite angles. We knew opposite angles were congruent because it's a parallelogram. Now these diagonals are actually cutting them into equal pieces. So you can see I marked these two little red pieces. These are equal to each other. And since this angle opposite it is the same, these two little pieces are the same as these two little pieces. Okay? And same on this diagonal. Okay, now these angles over here don't equal these red ones, but they're equal to each other here, they're equal to each other here in a rhombus. So that's, hopefully you've made you're working on your nice foldable to show these properties of a rhomba. I'm going to pause that and then have you go to do a couple of examples first. I'm going to pause it. I'm going to go ahead and call this part 1, and then go to part 2 in a little bit. Go ahead and finish your foldable nice and neat, and then you go to part 2 and see some problems with this.